Welcome to the concepts of classification of organisms for the first semester BSc Zoology program. And here we are dealing with a third system under the modern systems of classification, namely the Phyletics. It is otherwise referred as evolutionary taxonomy or evolutionary systematics. And the classification is based on the ancestry degree of divergence among descendants of a common ancestor. That is, how far the descendants differ among them. So the descendants of a common ancestor differ among themselves. Okay, so that is what is those things are being taken into account while classifying the organisms. And here we involve or make use of the study of morphological characters as well as phylogenetic relationship. So in the cladistics, we saw that there we take into account only the phylogenetic relationship, and the morphological characters are completely new. But here we take into account the morphological characters along with the phylogenetic relationship in phyletics. Okay, and regarding the morphological characters, we depend more on the homologous characters and analogous characters. Obviously, we take into account the epimorphic or what you call plesiomorphic characters. We also take into account the closeness, the what you call the evolution of descendants from the common ancestor, everything. But along with that, we also take the homologous characters into account while classifying the organisms. Obviously, only the homologous and analogous characters which do have importance in evolution is taken into account, not all the characters. So other characters are given less significance. Why homologous characters are given more importance? Because homologous characters are direct evidence for the process of evolution. Homologous characters show that, for a few examples, for example, birds, the wings, the forelimbs, then dolphins, flippers, horses, the forelimbs. All these are originated from the same structure, that is the forelimbs of a common ancestor. Even though they perform different functions and externally they all look different, but internally, if you see, they all have similar structure. And this has been discussed in one of the previous presentations, and we saw that all the forelimbs of these animals which we have mentioned here, they all have the same structural skeletal pattern. That is, in the case of forelimbs, it is the humerus, the first bone, the upper arm bone, then the radius and ulna, radio-ulna, that is the lower arm bone, then the carpus, that is the wrist bone, metacarpus, then phalanges. Okay, so these are the structural pattern in all these animals, whether it is flippers in the case of what you call a blue whale or dolphin, or as in the case of what you call bat or birds. Okay, or in the case of what you call horses. So in all these cases, the structure it is internally it is same. So it shows that all these organisms have taken its origin from a common ancestor, and that ancestor had this particular structural pattern of their forelimbs. Okay, so these structures are known as homologous structures or homologous. These are the homologous characters, and these homologous characters show that phylogenetic relationship. Okay, from a common descendant. From a common ancestor, descendants from a common ancestor. Okay, against this we have another what you call concept. It is the analogous characters. What does analogous characters? So analogous characters are those characters which may look externally, may be looking similar because of the functions they perform, because of the habitat they are in, because of the adaptations, similar kind of adaptations they have developed, but they may be originating from different ancestors. Okay. For example, if you look into the flight adaptation, butterflies can fly, insects can fly, you can see the bats can fly, birds can fly, right? But when we compare the characters over here, it is different in the sense the structure of what you call wings of butterfly is not the same as that of the vertebrates. Okay, they are different. So why it is so? Because they have different ancestors. So that those are known as analogous characters. So when we have a set of organisms and we see that this set of organisms have homologous characters, that means these have originated from the common ancestor. Instead, if we find that these set of organisms have analogous characters, obviously they have come from different ancestors. So that is how we can include the morphological characters or anatomical characters and the phylogenetic relationship along with that for the sake of phyletic system of classification. I hope it is clear. Okay, right. Thank you.